Thank you, sir. Thank you, guys. So once again, we are going to start with discuss with 2D geometry. Yesterday, just 2 points that I have completed regarding to the coordinate system. And yesterday, I have completed the distance formula. 1 or 2 examples that I have discussed. The second example, second concept is that is the section formula. And corresponding examples also discussed. Now today our concept is the nature of the triangle. It is the nature of the triangle. Nature of the triangle. So here the different types of the triangles are there, depends upon the sides as well as an angles. Hope you can understand. ABC, as I have given to you, ABC are the vertices of the given triangle. So according to their vertices, the length of the sides we can define, and according to their angles, we can also divide it. Yes, the third point to be noted is the nature of the triangle. The first point under this concept is what we can call that is scalene triangle. Scalene triangle. Yeah, so everyone is known regarding to this triangle. So here all the three sides are different. Suppose, for example, if I'm finding the length of AB not equal to the length of BC, not equal to the length of AC. Hope you can understand my point. Suppose the length is A, and this length is B, and this length is C. All the three sides are having the different length. If it is 2, if it is 3, it is root 5. The length of all the three sides are different. We can call it as a scalene triangle. Second point, this is an isosceles. Second one is isosceles, that is isosceles triangle. Isosceles triangle. So this is also a well-known property. If any two sides are equal, that is AB is equal to BC, and AC value is different. AB is equal to BC. If any two sides are same, so not necessary only AB and BC are same, only AB and BC are equal, but also you can rotate them. BC is equal to AC and AB length is different. If any two sides are same, then we can call it as an isosceles triangle. Isosceles. The third one is what? It is a equilateral triangle. Equilateral. If length of all the three sides are same, I can write BC is equal to AC and AB is different. AC is equal to AB and BC is different. The third point to be noted in this concept is that is an equilateral triangle. Equilateral triangle. Equilateral triangle. So this is also a well-known property. If the length of all the three sides are same, that is AB equal to BC equal to AC, that is called an equilateral triangle. These are all the well-known properties already we have studied in lower classes. Now I am going to discuss with respect to an angle. With respect to an angle, and even we can make use of a right angle triangle, an isosceles triangle. That's a right angled and isosceles triangle. By using an angle, already you know that whenever the sides are given, the vertices are given, how to define those properties. I'll try to discuss with the fourth point. But before that, out of the three, suppose CA is the largest side. I'm going to take next fourth point, point number 4. Out of the three, AC is the largest side. Largest side. I mean, the length of the side is greater than the rest of the two. Then the following properties are going to define. The first one, it is a right angled triangle. The first one we can call it as a right angled triangle. right angled triangle. Right angled triangle. So when the sides are given, the vertices are given, how we can say that it is a right angled triangle? You know that AB square plus BC square is equal to AC square. That is by using Pythagoras theorem what we can call that. And even the second point B, the right angled isosceles triangle, right angled isosceles triangle, isosceles triangle. This is what we can call any two sides are same, and even we can satisfy the right angle property. What is we can call? We can satisfy the right angle property, that is AB square plus BC square is equal to AC square, and any two sides are equal. We can take AB is equal to BC. AB is equal to BC. Right angled isosceles triangle. Right? Suppose if I am taking right angle triangle here, at which point it is forming a right angle, that is at B. Let it be taken as A, and it is C, and it is B. Right? So if these two sides are same, and even it is a right angle triangle, we can call it as a right angled isosceles triangle. The third point, point number 3, acute angled triangle. Acute angled triangle. Right? The acute angled triangle means some of the squares of the two sides. Some of the squares of the two sides. AB square plus BC square, which is greater than AC square. We can call it as an acute angled triangle. The fourth one, that is a D, obtuse angled triangle. Obtuse angled triangle. Whenever the vertices are given, that we people are discussing here. When angles are given, just it's very easy. Just we can take the sum of the angles of a triangle. That's very easy to discuss with these 3 or 4 points. Now you can take an opposite inequality, AB square plus BC square, which is less than AC square. These are the 4 points related to your triangular properties. Properties of the triangle. Let's have an example related to these 4 points. Just make a note of this. Try to maintain the notes, please. Let's have an example related to this concept. Total 4 points that I have given to you related to a nature of the triangle. Example. Number 1. The triangle with the vertices. The triangle with vertices. With vertices. What we are going to take, -2, 4. The vertices are given. And another vertex is 0, 0. The third vertex given as 5, -1 is. So any one of the 4 points can be happened. It's also depends upon the length of the sides. Let's have to check and try to post your answer, please. Just 1 minute problem, make it fast. You can find out the length of the sides and you can compare with the following conditions. Total 4 points I have given to you. And you can post your answers, please. Make it fast. Hope we can do this problem. The question is so simple. Which type of triangle is formed by the three vertices. Let it be considered as ABC and then you can proceed. Or O origin is given OAB and then you can proceed. Origin is given to you. A is given to you. B is also there. You can find out the length of the sides. Scale in a right angle. I'll give the options. Right angle triangle, obtuse angle triangle, acute angle triangle, isosceles triangle. Scale not given. Okay. Right. As I told Arshana, as I told, yes, very good. Obtuse, acute, right angled isosceles. Very good, very good. Good job, guys. Good job. Based upon the options, very good. Yes. Let's have the length of AB. I'll do here. Yes, sir. Very good, guys. AB, the length of AB, just I'm finding. What is the length of AB square or AB value? That is under the root of 2. And let's find out BC also. That is square root of 26. Next, AC value, if I'm finding, it is square root of 74. Let's have the comparison. Clearly, what I can say, AB square plus BC square is less than AC square. If it is less than AC square, let's see here which one of the following. That is by point number D. D says what? It is obtuse angle triangle. Obtuse. This is by point number D. Obtuse angle. Good job, guys. Let's have one more question related to this triangle concept. Second question. The vertices are given as like this. Problem number 2. Example number 2. 4, 3. Minus 3, 2. 1, minus 6 is here. It is also he has given obtuse, acute, right angle lies on the same line. Yes. Acute, obtuse. Acute. Okay. Let's have the length of AB, BC, and AC. AB, if I'm finding, the length of AB is equal to under the root of 49 plus 1, that is equal to square root of 50. BC is equal to under the root of, that is 4 square 16 plus 64, that is 8 square, it is 64, under the root of 80. AC I am finding under the root of 3 square, it is 9, 81, under the root of 90. As we have given AB square plus BC square, AB square plus BC square. What is AB square? It is 50 plus 80 greater than 90. AC square value. As you told, it is absolutely correct. Acute angled triangle. Okay. Very good, guys. Very good. Very good. Let's have the next question. Before going to that, one more point are going to discuss here. The next point, it is one of the most important point, as you know. Point number 4, area of the triangle. Fourth point is what? It is area of the triangle. Area of triangle. So everyone will remember this area of the triangle formed by the vertices ABC, but out of which 3-4 points will be given to you. First one, area of the triangle O 0, 0, A x1, y1, B x2, y2. So when one vertex is given, then it's a simplest format, that is x1 y2 minus x2 y1. This formula everyone knows. The second one, area of the triangle when 3 vertices are given. Area of triangle when 3 vertices are given, that is ABC, is equal to half into, this is a general formula, x1 y2 minus y3, x2 y3 minus y1 plus x3 y1 minus y2. Sometimes we may confused which one is first, which one is second. At that time, you can make use of even determinant formula also. R 1, 2, 3 is the first one. Next 2, 3, 1 suffix values. Second one, third one 3, 1, 2. Let's observe the suffix values 1, 2, 3, 2, 3, 1, 3, 1, 2. You can rotate them in a cyclic order. You will get the required formula. Or even we can also define as by using determinant concept, half into modulus of x1 minus x2, y1 minus y2, x1 minus x3, y1 minus y3. This is the formula. If you are expanding this, that is A, B, C, D, half into AD minus BC. You will get the required answer. This is the second point, is everyone knows. But the third one is important for us. Point number 3. This is important for us. Area of equilateral triangle. Area of equilateral triangle. This is important for us. Area of equilateral triangle. Here again 2 points are given to you. Under this, the A point, area of equilateral triangle, A point, root 3 by 4 A square, root 3 by 4 A square, where A is length of the side. Where A is length of side. A is length of the side. And B point is This is also well-known formula, h square divided by root 3, where h is what? What is h? It is an altitude, length, or height of the triangle. H is length of the altitude. Length of altitude. Or even we can also call it as height of the triangle. Height of the triangle. If I'll consider the triangle, if it is an equilateral, let's have the vertices ABC. If it is an equilateral, whose length of the sides will be A, or another possibility is what? When the height of the triangle is given, that h is given. So these are the two important formulas to be noted. The next point number 5. Make a note of this fourth point, please. If you're having any doubt while class is going on, you can raise your hands so that I can understand you have the doubt. So we can unmute you. These are the directive formulas, nothing we are going to do here. But the problems, the time management is important in mathematics because we need to solve. Very good. We need to solve total 80 questions from maths A and B. And especially geometry, it is a time-taking process, few of the questions, especially in geometry. Now I'll go for point number 5. Let's have the fifth point, collinear points. This is also one important property, collinear points. Three points, A, B, and C. 3 points, A, B, and C are said to be collinear if they lie on the same straight line. You know the definition of the collinear points. 3 or more points. 3 or more points are said to be collinear. Are said to be collinear. Collinear if they lie on same line segment. Same line. Sir, how we can define, how we can check? Let's have the discussion of this concept. The first one, the 3 points A, B, C are said to be collinear. A, B, C are said to be collinear. Are said to be collinear. The first point to be noted is the sum of the two sides is equal to the third side. AB plus BC is equal to AC, or AB plus AC is equal to BC, or this concept I am using in 3D geometry, especially AC plus BC is equal to AB. This is the first point to be noted. Sum of the two sides is equal to the third side. Not necessary to take only AB plus BC. You can rotate them in a cyclic order. If any one of these three properties satisfy, then the given points are said to be collinear. Point number 2. Area of the triangle formed by the vertices is equal to 0. Area of the triangle formed by the vertices equal to 0. That means here BC is there. It is a horizontal line. A point is somewhere else. Suppose A point lies on BC only. A point lies on BC. Then we can have the property of the collinearity. A point lies on the same line segment. Then there is no area can be formed for the triangle. Triangle cannot be formed whose area must be 0. Area of the triangle is 0. We can call it as a collinear points. Next, point number 3. Slope of AB is equal to slope of AC. Slope of AB is equal to slope of AC. Because they lie on the same line, slope must be same. You know that how to find out the slope. Slope m is equal to difference of y coordinates upon difference of x coordinates. That means y2 minus y1 divided by x2 minus x1. So these are the 2 points related to the nature and area and collinearity. And after that, we'll go for the center of the triangles, please. Still, we are in prerequisites. We are recalling the previous concepts. Let's make a note of the third point. This is an important for us. Even this point is also important for us. The third one, area of an equilateral triangle and collinear points are also important for us. As I told, if you're having any doubts while class is going on, you can raise your hands, please. No problem. Yeah, can I discuss the problems related to this concept, please? How the questions are asking related to this concept? The questions are, the 3 points will be given to you. Example 1. The vertices are given, the points 0, 8/3, 1, 3, 82, 30 are vertices of first option obtuse, acute, right angle, fourth one, lie on same line. Lie on same line. Whenever we have the condition for collinearity, I'll try to go for collinearity first, because it's very simple how to do this, making use of the slope concept. If it is in 2D geometry, this will be useful for us. That is in 2D geometry, this will be useful for us, not in 3D geometry. And in 3D geometry, I can make use of this concept. In 3D geometry, first point can be used. Even in 2D geometry, the first point can be used. But the area of the triangle and slopes cannot be used in 3D geometry because Z coordinates is also included in 3D geometry. We cannot find the slope of the line segment in 3D geometry. Hope you can understand. Second and third point I cannot use in 3D. So let's go for the vertices of either the obtuse, acute, right? As I told, whenever the line segment is given, you can go for the collinearity concept. Try to find out the slope of AB and the slope of AC. And identify whether it is correct or not, whether my answer is correct or not, please. First, I'll try to go for option number 4. They are same, Abhinav. Very good. Abhinav got 1/3 as their slope. Lie on the same line. Because it is very simple. Instead of finding the distance, AB, BC, and AC length of the sides, just we can do the collinearity concept first. If it is not correct, the fourth option is not correct, at that time we can go for the rest of the 3. Yes, very good, very good. Pavan, Isra, Hiraj, Durga, Janaki, Sharanya. Very good. Option number 4. Very good, guys. So clearly, you are saying that 1 by 3 is the correct answer within the given time. Just it is very good. Aisha, Avinash, very good, guys. Right. So let's see. I'm finding the slope of AB. First point, let it be considered as A, and this is B, and it is C. Let's find out the slope of AB. If I'm finding the slope of AB, y2 minus y1 divided by x2 minus x1. This is equal to 9 minus 8 divided by 3. This is equal to 1 divided by 3. I'm finding the slope of AC also. When I'm finding the slope of AC, AC means 30 minus 8 divided by 3 by difference of x coordinates 82 minus 0. This is equal to, it is 90. Yeah, so it is 30 minus 8 divided by 3. That means it is 90 minus 8 divided by 3 by 82 is equal to 90 minus 8 means it is 82 by 3 divided by 82. Your 82 will get cancelled. Your answer is 1 divided by 3. As you know, the slope of AB is equal to the slope of AC. So your answer is lie on the same line. Second example, please. Example number 2. Second example. If the points k comma 2k, 3k comma 3k, and 3 comma 1 are collinear, then k is equal to how much? Are collinear, then k is equal to how much? You can make use of either area of the triangle, or you cannot use length of the sides. That is not useful for us. First point cannot be used. Second and third you can apply. If you are applying the distance formula, it is complicated. It takes time also. Better to go for point number 2 or point number 3. So if you are perfect in synopsis, the formulas what we have given, you can able to give the answer. And as I told, these are the previous questions of your EAMCET. Make it fast, please. If you want, we can take area of the triangle formula also. Area of the triangle is equal to 0. Okay. Very good. Very good, guys. Very good. Very good. Yes. All of you are getting the same answer. Very good. Very good. Yes. Right? This is minus 1 by 3. How you are getting this? The slope of AB is equal to the slope of AC. Apply cross multiplication, you will get the k value directly. I am finding the slope of AB. The slope of AB is equal to the slope of AC. Already he has given they are collinear. Slope of AB means directly 3k minus 2k divided by 3k minus k is equal to slope of AC means 1 minus 2k divided by 3 minus k. The left-hand side value is how much you are getting. It is 1 divided by 2 is equal to 1 minus 2k divided by 3 minus k. Why? Because kk values will get cancelled. 1 times of k, 2 times of k, kk cancel. You will get just 1 by 2. 1 means 3 minus k is equal to, just multiply with the 2 on numerator, 2 minus 4 times of k. K will be on right hand side. 3 minus 2 is equal to minus 3 times of k. K is equal to minus 1 by 3. Absolutely correct what you said. If you want, we can apply area of the triangle also, but it is also complicated. According to the situation, you can apply the formulas. Which formula is applicable for us? Let's have another example related to this area concept. Question number 3. The maximum area of triangle formed by the vertices formed by 0, 0, a cos theta, b sin theta, a cos theta minus b sin theta. In square units is asking. When the options are also given to you, 3 by 4 times of AB, AB, AB divided by 2, A square, B square. The area is to be maximum. That is what he is asking. If area is maximum with the given vertices, let's identify the correct option, please. We must have that much of patience, because during morning hours from 8 to 6, how you are busy, that I can understand. I'm also taking the classes for IIT students. We can understand how much patience that you people are having. So after 6 or 7, still you people are listening our lectures. That is appreciated to you people. Make it fast, please. Related to the area of the triangle. Remember which formula are going to use. That is important. Which point are you using? 1, 2, or 3? If one vertex is horizon, can we use the first formula? If one vertex is horizon, make use of the first formula. I mean, I'll consider this as horizon. I'll consider this as a x1, y1. And I'll consider this as a b x2, y2. Third option, second option. Okay. Option number 2, option number 3. That AB value means which is option number 2. Option number 2. Okay. He's asking the maximum area, Nana. Let's have the discussion. We have some doubt regarding to this question. Yes or no? We know the formula for finding an area. The area of the triangle formed by the vertices OAB. As we know, it is half times of modulus x1 y2 minus x2 y1. So hope you can understand 1 divided by 2. x1 y2 minus x2 y1 means how much I am getting here? Minus AB sin theta cos theta. Minus AB sin theta cos theta. Minus AB sin theta cos theta. This is equal to half into 2AB sin theta cos theta. 2AB sin theta cos theta. Very good. Let's have the discussion continuation. 1 divided by 2. I can take AB outside and in modulus minus will be vanishing. Can I take 2 sin theta cos theta? For maximum area, that is AB, is it sin 2 theta? What is the maximum value of the sine function? The sine alpha, let us less than or equal to 1. Minimum value of sine function is -1. Maximum value of sine function is +1. To get the maximum value, what is the value I am going to substitute here, where sine 2 theta is equal to 1. I can take sine 2 theta as 1. That means theta value is how much I am going to take pi by 4. Where theta pi by 4, I can get the maximum value. I can put theta as pi by 4. He's not asking the value of theta. What is asking? Maximum area. The maximum area of the triangle formed by the given vertices. That means your sine 2 theta value will take 1. Because your maximum value in sine function is 1 only. Right? So we cannot take theta as, sine 2 theta value as 2. I cannot take 2 this value because the maximum in sine function is 1 only. So we can represent, we can take this sine 2 theta as 1. That means theta value I can substitute, I can take it as pi by 4. What is your required answer? As you said, most of you people, third option is correct. Option number 3. So how the questions are asking and how we people are approaching, moreover, related to our area of the triangle, 3-4 formulas I have given to you, and which formula is applicable for the given question, that is important for us. If you are using the second formula, it is complicated. One more step will be added to the given question, given answer, right? So let's observe the vertices and you can proceed. Hope you can understand the today's concept, please. The two topics that I have discussed, the nature of the triangle, area concept. Only two concepts I have discussed. And after completion of your introduction, we'll try to discuss the problems. Exercise problems are also there. I'm doing only solved examples, Nana. We have an exercise which includes 50 to 60 questions. You don't bother about it. Number of questions are there from each chapter. So still we are in introduction. We are solving just 1 or 2 questions from each concept, and still centroid, orthocenter, circumcenter, that is in the next class. I'll try to discuss centers of the triangle. That's it for today. If you're having any doubts, you can raise your hands. You can discuss. Otherwise, we'll close the session, please. If you're having any doubts related to today's concept. Thank you, guys. Good night to all of you. Good night. We'll see you next class. Right, guys.
Thank you, sir.